October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. We roll back now to 1958, but within a year's time, roughly 380 megawatts of generation capacity will have been made available to New South Wales and Canberra via the Guthaga and the Tumut 1 power stations. The Upper Tumut development, however, pushes forward prior to this taking place, with plans to increase catchment yields and also begin the first interbasin transfer operation by impounding water from the Tumut River, which naturally flows to the Murray River through the lower Tumut Plains. We look back now to the years between 1958 and 1961, with Lake Yucumbene filling, the Tumut Dam, the Tantangra Dam, the Tumut 2 power station, and other sundry elements to the primary developments in the Upper Tumut system coming to completion. By 1961, the addition of these elements would permit excess flows from the Murrumbidgee, the Tumut, and the Tumut rivers to be diverted and stored within Lake Yucumbene, or Tumut Pond, and increasing combined generating capacity to roughly 660 megawatts, making this energy capacity available across New South Wales, Canberra, and additionally Victoria, via an interlink within the Snowy Mountains scheme between the two state networks. Let's now look at the heart of the Snowy scheme, Lake Yucumbene, its dam, and the construction of its other elements associated with it. Lake Yucumbene serves as essential storage to the Snowy scheme, holding excessive runoff from both the Snowy Murray development as well as the Snowy Tumut development. The dam itself got underway in 1954, but only commenced filling operations after 1958. Interesting to note, however, the dam was initially built without a spillway, with storage levels being managed always remain below 90% capacity levels approximately. The spillway would later be built, but it is understood it was only ever dry tested. Lake Yucumbene is the main source of water through the scheme, but several other sources were also tapped into. As shown here, water can enter Tumut Pond Dam from Lake Yucumbene, but also a second source is available from Tumut Reservoir via its own Trans-Mountain Tunnel. A portal was driven from Tumut Dam towards Tumut Pond, with the Tumut outlet being positioned beside the one from Lake Yucumbene, as seen here under construction. Tumut Dam, as previously noted, would impound the Tumut River and divert its course away from the Victorian Plains towards the Snowy Tumut system, resulting in the first interbasin diversions of the Snowy scheme. Tumut Dam would take 3 years to construct and be ready by 1961. Under the early stages of the Upper Tumut development, Tumut Pond and Tumut 1 power station and their link to Lake Yucumbene were the key focus. Work to divert the upper reaches of the Murrumbidgee River alongside the Tumut River would involve the construction of the Tantangra Dam and its intermountain tunnel between it and Lake Yucumbene, as seen here. Tantangra Dam, a concrete gravity dam, is located across a narrow divide of the upper Murrumbidgee Valley, and its transmountain tunnel would move these impounded waters towards Lake Yucumbene, which is located in the Snowy River catchment, and then back again to the Tumut catchment via the Tumut 1 power station alignment. This initial transfer occurs via the Murrumbidgee Yucumbene tunnel, which enters Lake Yucumbene in its northern boundary nearby Providence Portal. Tantangra Dam would take 2 years to construct between 1958 and 1960, and like most dams in the scheme, require a diversion system to manage the large influxes of water between seasons. The Upper Murrumbidgee catchment, I understand, is capable of completely filling an empty Tantangara reservoir within 1 year from just normal runoff conditions. So this reservoir enables these waters to be diverted to produce both electricity and also enable management of the waters for future irrigation use throughout New South Wales. Towards the end of the dam's construction, flashboards were added in an attempt to prevent spilling and loss of catchment yield, as is visible. However, even the additional height of these flashboards did not prevent spilling in the year of its completion. So now, via the Tantangara Reservoir, water can enter Lake Yukonbeam, where long-term storage can occur. Following the need for water, it can be released towards Tumut Pond, where it joins waters transferred from Tumut Reservoir. From this point here, it then enters the Tumut 1 power station. But from the power station's tailwater tunnel, it otherwise resumes its natural path down the Tumut River. To leave it unchecked in this manner would mean the potential energy available would be lost. So it's here where Tumut 2 power station comes into its element. Tumut 2 power station follows a remarkably similar structure to Tumut 1, both being underground facilities. Both use pressure tunnels and pressure pipework to bring water to the turbines, and also use numerous surge arresters upstream and downstream of key mechanical and electrical assets. The plan layouts differ somewhat regarding means of access. Overall though, Tumut 2 would also be fitted with 4 turbines and generators of identical flow capacity, but marginally different pressure head ratings. Tunnelling would be underway alongside construction of the power station across the years of 1958 and 1961, in parallel with the Tumut and Tantangara works. Like Tumut 1 power station, excavation of the machine hall would require roof support systems be installed first. I understand this time, however, more reliance on rock bolting was possible, and this simplified the concrete support roof arrangement. With the roof secure, like T1, works progressed downwards to the base of the facility, prior to then being built upwards prior to fit-out of the equipment. Over the years, an international following had occurred, with many photos showing international delegates and experts from around the globe frequenting the complexes on regular bases, appreciating the engineering knowledge and construction techniques under development. For Tumut 2 power station to operate, water was required to be impounded downstream of Tumut 1's tailrace structure. The Tumut 2 dam was built roughly 1.6 kilometres downstream of this point to provide a storage buffer and feed Tumut 2 power station. Tumut 2 dam would be basic in nature, being a concrete gravity dam like many across the scheme. What is fascinating to know is that Tumut 2 pondage is very small, with the 2 power stations essentially always run together. Having identical flow rates through their turbines reflects this. It is possible for one to operate without the other via either river releases from Tumut Pond or overflows from Tumut 2 Dam, but this would result in lost energy capacity to the overall scheme and would likely be avoided in most cases. Tumut 2 power station has a large upper surge chamber, like Tumut 1, and other facilities such as Guthaga. Tumut 2, unlike Tumut 1, however, has inclined pressure pipelines leading to the turbines, and the placement of this surge chamber also appears below levels used in other complexes. Coupled to the top of this surge tank is a spillway, which when active overflows into 8 Mile Creek. This same creek also forms part of the aqueduct system linked upstream of the pressure pipelines, which feeds Tumut 2. The overflow spillway has been put to use over time and looks quite spectacular from historical photos. With works on Tumut 2 and other works in parallel concluding by 1961, the second below-ground facility was commissioned and further expanded the generation capacity of the snowy Tumut development in its upper areas. With completion and commissioning of these works across the snowy Tumut development, the upper Tumut system is now complete and contributing some 660 megawatts of generation capacity to New South Wales, Canberra, and Victoria. With these works concluding, the Snowy Mountains Hydroelectric Authority and its Commissioner William Hudson now shift their focus and efforts towards progressing with the Snowy Murray development, of which only the Guthaga system in the upper Snowy region has been built. The next two episodes continue the journey over the next 7 years by the authority, where the lower Snowy development would be built up and a further 1,500 megawatts of generation capacity brought online, raising the total of the scheme up to this point in time to 2,160 megawatts, or roughly 58% of its final nameplate total, as of its completion in 1973. Thank you once again for watching, and please look out for the next episode in this series, exploring and celebrating the Snowy Scheme and its 75th anniversary.